Okay, let's talk about polars and pandas. So the main advantage of polars over pandas is speed. If you need to do a lot of data processing on large datasets, you should try polars. There are two styles of API in polars for processing your data. Either you tell the API to do something and it does it immediately. This is how pandas works. And the second one, lazy. You stack a series of operations, for example, loading the data, filtering the data, summarizing the data. Lazy evaluation is where running a line of code means that the underlying logic is added to a query plan rather than being evaluated. Polar supports eager evaluation and lazy evaluation, where Pandas only supports eager evaluation. Eager evaluation means expression is evaluated as soon as it's encountered, where a lazy evaluation refers to evaluation of an expression when needed. So let's start with this Python code, and with this code we will execute 8 different tests between polars and pandas. Okay, and before starting, I want to introduce you about the data we will use for testing. And for testing, we'll use data.csv, and it is about 470 megabytes. And it's not so small and not so big. It's a good sample for testing. Um, okay, and for testing purposes, we're gonna use Numpy, and with that, I prepared some help functions from utils.py, and I importing a testing function. I'm importing a show results function. It is showing result on the terminal. Also, I want to show a graph which shows results in our test, and then I need to orchestrate all these three functions above with one orchestration function. And before testing, I just want to introduce about one module that we will use for testing purposes. And it is a timeit. It is a standard module from Python, and timeit has much of functionality for testing specific functions for your use case. And timeit requires a couple of parameters. So the first one is err. Err means calls the timeit repeatedly, returning a list of results. For example, if we run a specific command in Python, it runs it 5 times and then it returns a list of durations of each run. Okay, and another parameter is n. In our case, n equal to 10. And n means how many times to execute the full statement. So these two parameters we will use for our test. I think it's enough, and you will see the result at the end. One more thing before testing. You should know that each test has its own conditions, and you can define these conditions in Python variable. For example, for pandas, we must import a pandas module as PD, and for polars, we must import polars as PL. And these functions is executed before each test. You can change these conditions for each test separately, and it is possible, sure. And for example, if you go to this test number 1, we will try to compare the speed of reading a single CSV file. And as you can see, here is statement for pandas, here is statement for polars, and each statement is executing just after we executing these conditions. Okay, and for pandas, we are trying to execute pd.readcsv, and for polars, we are trying to do pl.readcsv. As you can see, this pd is coming from here and pl is coming from here. So, and after this, we are passing all parameters to test it function. As you can see, here's a testing conditions, here's a statement, here's r and m parameters. And if you see this tested function, we are passing all these parameters to this Python timeit functionality, and it will returns us durations of each experiment. So, okay, this is test number 1, and we will run the full file after I explain another one's experiments in our Python file. So that's for test number 1. For test number 2, we are trying to select columns from preloaded CSV file. Please keep attention to one thing. In setup conditions for pandas and for polars, now we have additional one line. We are having a read_csv for pandas and read_csv for polars. Why? Because in this experiment we are trying to compare the speed of selecting columns function itself. So we need to load a CSV file before to compare the selecting function. So for this reason, we are moving this reading procedure in condition stage, because this part is executed before each compared function. Okay, and now we must to define statement for pandas and statement for polars. And in this experiment, I have defined my statements before, so I just copy and pasting. This is for pandas, and for polars it will be, here you go. So we're having statement for pandas, statement for polars. As you can see, we are trying to select the same combination of columns for pandas and polars. We are having our setup for pandas and polars. We have our statement, we have R and N parameters, and of course experiment name. Okay, this is for test number 2. So now we are ready to go to test number 3. Okay, test number 3. And in test number 3, we also trying to compare selecting function. But what is the difference? Okay, for pandas, it is the same. We are using the same statement. But for polars, we use a different one. And here you go. And the difference is that we are now using select function, which is much faster than this way. So we'll compare the if select functionality in polars works faster than standard functionality that we use in pandas also. Okay, this is about test number 3. So it is like a improved version of selecting columns in dataframe. So, and that's it. Now we are ready to go to test number 4. Okay, and test number 4, it is a filtering. And in this experiment, we will try to compare how pandas and polars will try to filter data in dataframe. So for pandas, we'll use this statement. It is a pandas dataframe, and we'll try to execute query function in pandas, and argument it is column 1 should be more than 5. Okay, and we should passing alternative functionality in polars. Okay, and in polars we will have this statement. As you can see, one difference. We have a filter function, and the main question, does the query or filter function is faster? Query is coming from pandas and filter is coming from polars. And we try to use the same filtering condition. Column 1 should be more than 5. Okay, and testing conditions are the same. So this is about test number 4, filtering. Test number 5, it is right here. In test number 5, we will try to create a new column in pandas and polars. As you can see, we are having version 1 and version 2. So in test number 5, we'll have version 1. This is a standard way to create a pandas column. And in pandas, we are doing like this. We are, for example, creating a new column. It's named new col, and the values in this new column is column number 1 multiplied by 10. So for polars, we should pass alternative function, and it is a polars then with columns. It is a special functionality working with columns in polars, and we are passing this conditions. And it is the same as we passed for pandas. We multiply by 10 this column 1 column, and alias is new col. Okay, and as you can see now, in this case, we are having a little bit complex, but setup conditions for pandas and polars are the same. And this is for test number 5. For test number 6, we'll create a new column, but in a little bit different approach. So test number 6, we are creating a new column, but in a little bit different approach that I mentioned it before. And for pandas, we will use the same statement. It's a pandas, and we're creating a new column, and the new column values is column number 1 is multiplied by 10. It's the same as we had before in test number 5. But for polars, we will have a little improved function, and here we go. This is the lazy functionality that polars providing to polars users. And if you use a lazy, you can expect faster execution of your polars functions. Okay, and so we are trying to use a lazy functionality, and then we are trying to call the same with columns as we had before, and the rest part of our statement is the same as we had in test number 5. Okay, so one difference that we are including this lazy functionality for polars. That's one difference, but it's a critical difference. Okay, and the rest conditions are the same. This is for test number 6. So, test number 7. And test number 7 is for grouping and aggregating. So, for pandas, we'll use this statement. It is group by. It is the very popular functionality in pandas, which are executing aggregation based on columns or conditions, and it's aggregating by function, for example, mean or standard deviation or etc. etc. Okay, so for pandas, we try to use a group by, and for polars, we are gonna to use also group by function. It is almost the same that we are having in pandas, just the engine is polars. And again, we try to use mean aggregating function. And as you can see, this is a shorter version of aggregating in polars. And we'll try to compare group by in pandas and group by in polars. So we'll see which one is faster. Okay, and the last test in our video is test number 8, and we'll compare how pandas and polars will works with missing data. So for panda statement, we'll use pandas, and we are selecting this column, and we'll try to replace missing data with minus 999. Okay, and for polars, we must use alternative function. And alternative function is polars, then with column functionality. Remember we had with column in our previous tests. And then we are trying to select column, for example, column number 2, the same as for pandas. And then we filling missed data with minus 999. This is the same as for pandas, but with a little bit longer line of code. Okay, that's all. And now we have defined all our tests. We have 8 tests at all. So, and now we can to run this Python file and we will get the results. Okay, are you ready to run this test.py file, which contains our 8 tests that we are caring about? Okay, and I want to create a new folder. It is images, and I want to save result graphical data in this folder. It is a graphical visualization which shows the duration of each test. Okay, and before that, I want to use this chronometer, which shows for you how real time takes each test. Okay, and I will keep it in here in front of your eyes. So I want to run this file, Python 3 and test.py. Okay, let's wait and enjoy. Okay, finally, this test, the first test, took about 10 minutes. And as you can see, in the test number 1, we have pandas duration is about 60 seconds, while polars took about 3 seconds. Okay, I will save this image and we'll go to the test number 2. Okay, and now we are going to run test number 2. So I reset timer and I close this graph. So, and let's wait for the result of test number 2. Okay, test number 2 took about half a minute, 30 seconds. And as you can see, it is selecting columns with version number 1. So pandas took about 0.03 seconds, while polars is almost 0. So polars is faster in selecting columns in your data frame. Okay, I'm saving the result of test number 2. Okay, test number 3 took half a minute, and the results are very similar. So pandas took about 0.03 seconds, and polars took about 0 seconds. Is working very fast by selecting columns in your data frame. So this is the result from test number 3. I'm saving it in my folder. Now I'm resetting the timer and let's run test number 4. Okay, test number 4 took about next half a minute, about 30 seconds. And here, okay, it surprised me. Polars works a little bit slower than Pandas, and it's about filtering. But remember, in filtering, we had, yeah, this filter function. So it seems that filter works a little bit slower than query. Okay, so I'm saving the result in my folder, and we are ready to see the result of test number 5. Okay, I'm resetting, and test number 5 results will come in a few seconds. Okay, and test number 5 took about 30 seconds, that's fine, and we having a polars works slower by creating a new column. And what we had in creating new column, we had two versions of this test. We had version number 1 and version number 2. And remember, on version number 2 we had lazy functionality. So without lazy, polars works slower than pandas. But it's very interesting to wait until test number 6. Okay, so let's run test number 6 and let's go. Okay, and test number 6, as you can see, if you're using a lazy functionality from here, we increase our speed a lot of. So polars took almost 0 seconds. It's working like a Formula 1, and pandas works much slower. So you see the difference if you use a lazy functionality. Okay, I'm saving the result in my folder. That is very interesting. Okay, and now we are ready to run test number 7, group and aggregate. Okay, grouping and aggregate took about 30 seconds, and as you can see, polars works faster. It took about 0.15 seconds, and pandas is about 2 times longer. So grouping and aggregating in standard ways, polars is winner. So I'm saving the result of this test number 7. Okay, and let's run our last test, and the last test is for missing data. I close this window and let's run our last test. Okay, and this experiment took about half a minute, and as you can see, polars works slower by filling missed data in CSV files in data frames. So pandas works much faster with this specific use case. So I will save my result in my folder, and we can analyze it by the end of this video. So I closing that. Here's the result of our experiment. I will deliver this result in the description of this video. Welcome now to the results section. We will evaluate experiment results into 2 separate groups. One group will include tests where we not use polar lazy functionality, and another group where we included lazy functionality. Let's start with the test number 1. With this test, we checked which one, pandas or polars, read a single CSV file faster. Here, pandas took 55 seconds, while polars just almost 4 seconds. So the winner is polars, which is faster almost 15 times. So the first point goes to polars. Test number 2. Selecting columns from our data frame. Version number 1. Remember, the version number 1 is about the most straightforward way to select columns. Here, pandas took about 0.03 seconds, while polars near 0. And the calculation shows that the winner is polars again, which is faster almost 71 times than pandas. So another 1 point goes to polars. Test number 3. Selecting columns from a data frame, and now we have version number 2. The only one difference from the previous test that we used select functionality for polars. And for pandas the numbers are the same, while for polars it's, let's say, almost the same. So again, the winner is polars, which in this case is approximately 8 times faster than pandas. So another 1 point goes to polars, and we have 0.3 polars is winning. Test number 4. Filtering data on data frame. As you can see, here the results are very similar, and for this specific use case, pandas demonstrated better results than polars. Pandas was faster approximately 1.1 times.
The first point goes to Pandas. And now we have 1, 3, Polars is still winning. Test number 5. Creating a new column, version number 1. In this test, Pandas demonstrated better result with 0.03 seconds while Polars took almost 0.13 seconds to create a new columns. But keep in mind, here we did not use lazy functionality for Polars. That will be in the test number 6. So for this time, 1 point goes for Pandas on that group where we not included Polars lazy functionality. Test number 6. Creating a column, version number 2. Version number 2 because here we are using lazy functionality in Polars. Only one difference. For Pandas results are the same. However, Polars demonstrated brilliant performance and now it is more than 120 times faster than Pandas. One strong point goes to Polars in a group with a lazy functionality. Test number 7. Group and aggregate. Here Pandas spent 0.366 seconds while Polars just 0.15 seconds. It is less than 2.4 times and Polars is the winner again. So another 1 point goes to Polars. Test number 8. Filling missing data. The last test in this video. Surprisingly, here Pandas was faster almost 15 times than Polars. For this reason, plus 1 point goes to Pandas. So the final results. If you use Polars lazy functionality, Polars is absolute winner with score 5 and 2 in our experiment. If it's not lazy functionality, Polars also wins with score 4 and 3 over Pandas. I think Polars has a bright future, so let's see. I enjoyed to show you this experiment and I hope you like that. Please subscribe the channel and see you in the next video.